Alright, so this is my first circuit that I built out of 4, and this is me showing off my 4 circuits that I built. And for this one, what it is supposed to resemble is it's supposed to resemble an arcade game. When you typically go to an arcade game, you would see the games where it goes around in a circle and it tries to stop on a certain number, and the certain places have different values. So for example, I'm going to start the circuit real quick. Okay, so the circuit started as of right now, and as shown, there's a red probe right here which represents 10 points. There's green probes which represent 3 points, and there's 2 points for the blue probes. I made this different by creating it in the game sort of setup, and so when it goes around it'll stop on a certain probe. And I made different difficulty settings. So for this one I only made 2 difficulty settings. I made the easy one, which is 75 hertz. Then I made a hard one, which is 500 hertz. And whenever I flip the switch, the input goes to either or. So for example, I have it on easy right now, so as you can see it's a little slower. And then when I put it to hard, it's a lot faster paced. And for this, I'm going to leave it on easy as of right now. And then my switch 1 up here will switch it off, so that way it will pause on a certain probe. So for example, for this spin I got 3 points. And the circuit's less of a random number generator, and it's more of a random probe generator. So that way, when the clock speeds or slows up the alternation, and that's how it does that. For my pin code major grade, what I did for this one was I started off first by generating concepts on what I could do for making this my own circuit. So for this, I used probes to test the different inputs, so that way it could be turned into essentially a lock. So that way whenever you input certain numbers, that it lights up a probe which symbolizes unlocking a lock. So I ran through, and all these different inputs are what light this probe up, so that way you have to get a certain number, and if you get a different number then it doesn't work. And then the second thing I did was I have the hex displays right here, and then I converted it to binary as well, so that way it can go in hexadecimal and binary. So I'm going to start off by doing a few examples. So I'm going to do that. I'm going to do that. And for example, it doesn't light up whenever I input the wrong code. But when I restart it, I could do this. I made it so that way it's when you input 1, 2, 3, 4, it'll light up a probe. So I'm going to work on inputting that code real quick. 3 and 4. So as you can see, whenever you input that, the probe all of a sudden lights up. So whenever you get that, then your lock with quotation marks around it is unlocked. And the switch is what transfers the number over, so it'll switch the number over. And then that's how the circuit works, and I think I explained that one well. Now on to my next one. That was my pin code major. The one before that was the random number generator game. Then now I transition over to my car alarm that for my different, making it my own, is what I did was I made it to the PLD board so that way I could program it to FPGA. So whenever I set off this one, it symbolizes the alarm being triggered and alarmed. So right now it's alarmed, and then once something goes open, then the LED will go off, so it signals the alarm being tripped or triggered. And so when you have one of the doors open, it won't go off unless you close it, and then it's armed again and you're back to normal. So that works for any single one of them. And right here is a flip-flop. It's a SR flip-flop that signals alarm when being triggered or when one of the doors open. So this isn't the typical SR flip-flop that you'd be given, but I made this so that way it can be represented and show exactly what it's doing behind what multi-sem is showing. And this switch right here just regulates the deactivation and activation of the alarm. These are all different doors being represented, and then this alarm being on, the alarm being tripped and triggered. Then on to my final one that I did. I did a hexadecimal and binary calculator. So as you can see, for the binary, when you're representing certain numbers, it won't show them because over here it's in hexadecimal, so the binary ones can't display that because they can only display up to 9. So that's where the hexadecimal comes into play with being able to represent numbers beyond 9, such as 10 through 15. And 15 is hexadecimal's limit. So it has different numbers you're able to play with for this. So the first row right here is what goes to the first display, so that way it can represent the first number being added or subtracted. Then the second one over here, the second set of switches, does the same thing and it alternates the numbers, so that way it can be utilized. And then whenever it's wanted to add or subtract, there's a switch right here that will switch it between adding and subtracting. So whenever it's adding, the probe is off, and whenever it's subtracting, the probe goes on, such as now. And then the switch down here is a memory setting that stops it from displaying anything else unless you switch it back. So whenever you switch it, it switches to ground, and that's how it stops. So it'll stop it there, and it will just pause it till it's switched back again. Alright, and those are my major grade videos